Good day, everyone. So today we'll be focusing on the number system, specifically on the real number system. Okay, so that means undefined values and imaginary numbers are not going to be within the scope of this video. All right, so within the real number system, we will learn firstly about natural numbers. Okay, and secondly, we will speak about whole numbers, followed by integers. Then we will speak of or learn about rational numbers. All right. And then we will compare rational numbers to irrational numbers. Okay. And in part two of the video, we will do examples of differentiating between a rational number and irrational numbers. Right. So let us begin. All right. So the first thing I said we're going to speak about are natural numbers, and they are represented by this symbol. All right. So these numbers are also referred to as counting numbers. Okay. So some people refer to them as counting numbers. And because we do not want to complicate this, already, if I speak of counting numbers, the natural numbers that come to your mind is numbers like 1, 2, 3, 4, and so on. Okay, so that is what a natural number is. And we use them in our everyday lives. Okay, so I'm just going to make an example where you would strictly need to use a natural number. If you needed to represent the position of an athlete, okay, or of a competitor, you will use a natural number. So you will have to say something like the competitor got the first place. Okay. Or in some cases, we say this is number one. Okay. The competitor got number one. So you are forced, or you have to strictly use natural numbers. Number one, number two, number three, number four, and so on. All right. So let's move on to the second category, which will be whole numbers. Okay, and this is the symbol for whole numbers. So whole numbers basically are all the natural numbers, okay, with the inclusion of zero. Okay, so we need to include the number zero. Okay, so that means when we think about them, we have to now start counting from 0, 1, 2, 3, 4, and so on. Okay, and we must take note that since these are whole numbers, okay, they do not include decimals. Okay, these are whole numbers, so we should be able to use them to count whole things. All right, and I'm going to make an example of where you will need to use now the additional number 0. Okay, because we've already made an example of where you will use the natural numbers. But now if you include 0, why would you need to do that? So if you think about a situation where you need to express having nothing, okay, having nothing or having no quantity. Okay. So one example would be to just say I have 0 balance. in my account. Okay, so that is where you will use the additional number 0, okay, for completion. Now let's move on to integers. Maybe let me just make some space for myself. I'm going to start writing on the left. Okay, so integers, this is the symbol for an integer, perhaps some additional space. Now, what I like about this is that all these numbers, they add on top of each other. Okay, so this will be all the whole numbers, okay, which we just learned about. All right, and then we now include all the negative. Okay, so again, we need to pay attention that it's not all numbers, it's all the whole numbers. Okay, and we also include negative whole numbers. So we're still not dealing with decimal numbers. Okay, so there's still no decimal numbers for integers. So you can already start thinking, so it's all negative numbers from minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. Okay, all the way to positive infinity. Now we've added the negative values, but where do they help us? Okay, so let's say you needed to express again, it needs to be useful in our everyday life. So let's say you needed to express negation, okay, or rather the opposite. Okay, so that is something like if you are in debt, how would you represent debt? Okay, so we can represent having money in the positive sense, having no balance with 0, but now being in debt. Okay, we need to be able to represent that. And we can express that scenario using the negative whole numbers. Okay, it could be any, but in this sense, we're still speaking of whole numbers, which can be used to represent negative, to represent that. Okay. All right. So moving on. Now I'm going to speak of rational numbers. Okay. And this is how we represent rational numbers in a symbol. Okay. So rational numbers are basically all numbers, okay, that can be expressed in the form a over b. Okay, so that means in a fraction form. Okay, but then we need to define the values of a and b. Okay, we're saying a and b must be integers. Okay, we've already touched on integers, we've already learned about integers, we know what they are. And b must not be equal to 0. Okay. So we can put in a quick test here. We can say if A, or maybe not A over B rather, if B is equal to 0, okay, A over B becomes undefined, okay, and that is not a rational number. Okay, so that's just a test that I'm putting. It's not the definition. The definition is that B must not be equal to 0. Okay, that is because if you were to put B there, then A over B becomes undefined. Okay, and we don't want that because we're dealing with real numbers as well. Okay, so now in this case, okay, we can include decimal numbers. Okay, so for rational numbers, we do include decimal numbers. All right, but there are rules that must be followed. Okay, so any of these should hold for it to be a rational number. So if it is a decimal number, okay, it must either be a terminating decimal. Okay, so an example of this will be 0.14. Okay, it ends, it terminates, it does not go on forever. All right, and the second, remember this is either, so the second consideration is one that has a repeating pattern. Okay, and an example of this, let me use the same 0.141414 continuous. All right, but because it has this terminate a repeating pattern 141414, okay, this can also be expressed as 0.14 bar. All right, so that means it is forced to terminate, and therefore it becomes a rational number. All right, the third and last consideration, it's now a repeating pattern still, but now it's only on one unit. Maybe I'm not even going to write that. I'm just going to add it as another example here. So let's say 0.6666666. Okay, continuous. So because it has this repeating digit, okay, 6, it can also be expressed or rewritten as 0.6 bar, and in some cases some people use dot, which is also acceptable. Okay, so this also becomes a rational number. All right, so in part B of the video, we will focus specifically on the rational numbers and irrational numbers with examples on how to determine if it's a rational number or an irrational number. Thank you.